Hello everyone, should be able to hear me now. Let me double check that. So what I'll do is I will also enter the meeting from here. Okay. So you should be able to hear me, all of you? Yes, great. Please put a comment if you can hear me. Okay, that's great. You cannot hear me? Okay, let's see. Maybe I can change something here. Let's join the audio. Okay. Please switch off the video, everyone. Kunal, Saurav, please switch off the video. Thank you. So this particular session is for class 9 and above, but you should be able to grasp it if you have some amount of background in geometry. If you were attending some of the Chinta seminars before, then you should be able to grasp it as well. Okay. Aryan Mukherjee is saying, can you start recording? Okay, sure. Maybe we can start recording. Let's see. Record to cloud. Okay, yeah. Great. So Manpreet Kaur, please switch off the video. Thank you. Maybe I can just put this in there. Yes. Anurag Mukherjee, please switch off the video. Yes, thank you. So the people in Facebook and YouTube, can you hear me? Can you hear my voice? Should be able to hear my voice. Okay, so let's start the discussion for today. This is a very interesting topic from basic geometry, but it involves an intuitive idea called Carpet's theorem. Maybe you have seen this before, maybe you have not seen this before, that's all right. We will be learning some parts of it. So this is called Carpet's theorem. Okay. All right. So I'm accessing the chat from here. So maybe I can go back to Zoom. Okay, here we go. So can all of you hear me in Zoom clearly? Not sure if you can. Please can someone? Yeah. Okay, that's great. Okay. Sounds great. So geometry, of course, is an art of measuring stuff. The moment you start measuring things, you are doing geometry in some sense. Measuring area, measuring length. There is an offshoot of geometry known as real analysis, or in fact, an offshoot of that known as measure theory. which really discusses the fine points of how to measure things. You must remember this. This is, you perhaps have encountered this somewhere else, that one of the most mysterious problems of antiquity was to measure the area of a circle. Area of a circle. Or even to measure the perimeter of a circle. Measure the perimeter of a circle. This is the question was so overwhelming that stalwarts like Archimedes or Aryabhatta has worked on it for centuries, and no definite answers were available until the time of Madhava. So maybe you have heard of Madhava from Kerala School of Mathematics, who about 200 years before Newton and Leibniz created something called the Madhava-Gregory series, where they first time gave a really scientific way of measuring the length of the perimeter of a circle. So why I'm saying you this is not a trivial problem. This is a very challenging problem to measure the area or volume or length of something. It's quite a challenging problem in itself. Now, today we will start with one problem that is given by this statement. Now we have already talked about the main theme. The main theme is area. The main theme is area. So there is a triangle ABC. Let's say here is a picture of it. Maybe I can use a pen tool here. So there is a triangle ABC. So here is a triangle ABC right down here. This is a problem from an American mathematical contest. It's a very beautiful problem actually. It uses a theme that has been used over and over again across the world in different math Olympiads. So in triangle ABC, the point D divides AC. Point D divides AC, so that AD over DC is 1 over 2. This is given. This is given data. Okay. AD over DC is 1 over 2. And E is the midpoint of BD. E is midpoint of BD. So, and F, so what you do is you join AE, and you extend it to meet BC at F. You extend it to meet BC at F. Now, if you do that, the question is, what is the area of triangle EBF? Area of triangle EBF. Given that the area of triangle ABC is 360. Area of triangle ABC is 360. So understand this problem very well. You take a point D, here is the point D, on AC such that AD by DC is 1 over 2. Then you also pick the midpoint E of the triangle ABC, midpoint E of the length BD. And what you do is you join A and connect A with E and extend it to meet BC at F. Okay. So this is the piece of triangle whose area you want to find out. Some said it's okay. Okay, sure. People are shooting answers. That's fine. But let's not go into answers. I mean, in some sense, answers or solutions are the least interesting part of a problem. the problem itself has infinitely many ways of looking at it. And so we will first enjoy the problem before just hitting on the solution. Okay. It's like a cup of coffee. Enjoy it. Okay. Enjoy the problem first instead of just trying to finish it off. Okay. All right. So the first thing we will do is we will look into this from a different perspective. There are a couple of ways of looking at areas of triangle. The first one that we will be interested in, well, the area formula. If you are not familiar with the area formula, then area of a triangle is half base into height. So if you have a triangle ABC, then you can just drop a perpendicular from A on the base BC, and the height is, let's call this height H. So the area of this triangle ABC is half base into height. That's something we already know. Okay. Now, some people are still trying to solve the problem. Let's not solve the problem. Just let's. What is the rush? Okay. There is no rush. Now, definitely a person, a layman, might ask you, why is this the triangle's area? Why this formula works? So that's a natural question. Anurag, please switch off the video. Okay. Why is this? Why is it true that area of a triangle is half base times height? Okay. So you can say, okay, maybe it's derived from the area of a rectangle or a parallelogram. Maybe that's true. But then what is the area of a rectangle? Maybe you will say, okay, it's length times breadth. You'll say the area of a rectangle is length times breadth. But then, of course, since the person who is asking the question clearly has not read any books, the person might ask, okay, why is the area of a rectangle length times breadth? Why is it not length squared times breadth cubed? Why is it not square root of length times b to the power 5 or something? I don't know, some weird number. So Ritam has a very nice answer that the notion of area is connected with the number of ways you can split the rectangle into several pieces. Okay, so see, just give me a moment to explain to you why this is true. Think about yourself. Think of yourself like a student of class 1, maybe. The first time people should be looking at this particular concept. So if you take a rectangle, let's say the width is 3 and the height is 3 and the length is 5. What you do is you split this rectangle into small boxes. You split this rectangle into small boxes, and each of these boxes, so how many small boxes are there? How many small boxes are there? Well, there are 15 small boxes. There are 15 small boxes. So when you say the area of this rectangle is 15, when you say area is 15, all you are doing is counting the number of boxes. Isn't it? All that you are doing when you are doing this multiplication 3 and 5, Ritik, please switch off the video. If you're multiplying 3 and 5, all that you are doing is multiplying the number of small boxes. Okay, but this thing can get a little bit more complicated. For example, maybe it is not 5, it is 5.5. It is 5.5. Then what do you do? Then what do you do? So there is a very concrete discussion that needs to happen when you have length and width of fraction or decimal value. So this is half, this is what? This is half a small box, half a 1 cross 1 box. What is the meaning of 1 cross 1 box? It's a small box, width is 1, height is 1. Srishti, switch off the video. So you count the number of small boxes. So you have this, you have this, you have this. So 3 half boxes and 15 1 cross 1 full boxes. So okay, you are still counting boxes. Now you're also counting part of the boxes, right? You're also counting part of the boxes. So 15 plus half plus half plus half. So it's 16.5. So remember, when up to now, when I asked you to create area formula, all that you were doing is counting boxes, nothing else. You are not doing anything else. You are just counting boxes. So finding out area is turning out to be a counting problem. It's not even an area problem, it's a counting problem. Because really, if you think about it, what is this empty space right here? I'm doing mathematics for like 50 years, 25 years now, 20 years now, maybe 20 years now. I still look at this empty space and I think, okay, what is this thing? Who said that the area of it is 1 or something? It doesn't make any sense to me in my mind. All we can make sense of is counting the number of boxes. That's it. That's all we know. But things will soon get a little bit more serious. It would be really hard to count the boxes if this fraction is ugly. What do I mean by that? So if you have a rectangle with width 5 and the height with root 5 and the height 2, how would you count the number of boxes anymore? Because this is approximately what, 2.28 dot maybe, I don't know. You can check this out in the calculator. Someone can look up the value. Square root of 5 is what? I don't know, 2.28. Okay, 2.236. Thank you. So how would you do it? How would you count the boxes? You can keep on making the boxes smaller and smaller and smaller, but what would you do? How would you count the total number of boxes? Because the process will never end. Because this decimal place is going over and over and over again. So my point is this. You cannot just tell me to multiply 2 and root 5 and ask me to believe you. Because even the process is an infinite process. Even if you are breaking down big boxes into small boxes, and if you're counting how many smaller boxes you have, that, okay, size of the box is square root of 5, okay, then you'll be having trouble with this 2 then. Because what you really need is to count the number of boxes of a standard size. And your standard size was 1 cross 1, right? You are either counting how many 1 cross 1 boxes you have, or you are saying, okay, maybe we can split it into halves and see how many half boxes I have. Maybe we can split it into fourths and see how many fourth boxes we have, and we can sort of put them all together and find an area formula. But if you just tell me multiply 2 and root 5, the process is a never-ending process. I can keep on splitting this big box into smaller boxes, and the process will never end. See, we are in trouble now because we don't even have an area formula unless we talk about something else. So what really happens here is that for 2000 years, human beings, Aniruddha, please switch off the video, okay? For 2000 years, human beings used a false formula for area. Because you cannot, by normal mathematical tools, you cannot make sense of the area formula until and unless you know how to tackle with infinity. And that's where the notion of limit comes in, which we will not go into today. To make sense of even the area formula, while length into breadth is a good formula for area, we need to know the notion of limit. And that human beings took about 2000 years to understand. And I'm not sure I still understand it very well. Because it's mind-boggling how it happens. Okay, it's mind-boggling. But let's look at the problem that we have. So for the moment, suppose we know that the area of a triangle is half base times height, fully understanding that this is not a trivial formula. This is a very complicated formula found by hundreds of years of hard work. So the why question is really will require to understand limit. But then for the moment, suppose we accept this formula. If you do not know limits, then we accept the formula. So what we do is we look into it from a different perspective. Instead of computing an area formula, we try to find out triangles which have equal area. So here is a simple kind of a, let me draw it here. So suppose we have two triangles with the same vertex A. Two triangles with the same vertex A, and their bases are on the same straight line L. So L is a straight line and A is a vertex. A is a vertex and L is a straight line. And what we do is we draw two triangles. So one of them is here, ABC, and the other one is maybe here, something like this, AXY. So we have two triangles, ABC, ABC, and AXY. What we will do is we will try to measure the area of both of these triangles. So to do that, we have to first think about the height. Good news is the height is the same. Because if you drop a perpendicular, this is the height. So height is h. But this is also really complicated. You see, there are subtleties here. There are subtleties here. When I say this height is h, what do I mean by the word height? It's not a simple thing. Okay, you might say it is you're dropping a perpendicular. But what is a perpendicular after all? Shivani has a very nice answer. Excellent answer. This is basically the fundamental notion of perpendicularity. What is after all perpendicular? You see, if you have a line and if you have a point outside the line, then suppose you want to go from this point to this line. You want to walk from this point P to this line XY. How will you do it? Well, the shortest path of doing that, is defined is defined as the perpendicular line. That is the definition of a perpendicular line. The shortest path of going from one point to a line. Now, mind you, this is not a trivial matter. There could be multiple shortest paths from a point to a line. From a point to a line. I'll show you an example. You can just change the notion of distance and you can have multiple shortest paths from a point to a line. So let's say, in fact, even you don't even have to go as far as a line from a point to a point. So if you have 2 points, P1 and P2, how many ways can you go from P1 to P2? What is the shortest path of going from P1 to P2? You might say, okay, maybe it's a straight line like this. Maybe it's a straight line like this. But wait, you still don't know, because you have to be careful. If you are on a circle and if you were restricted to a circle, suppose P1 and P2 are the 2 poles, then there are 2 ways from going from P1 to P2. So there is this one way of going from P1 to P2, and then there is this another way of going from P1 to P2. Both of them are shortest paths of from P1 to P2, provided you are restricted. Provided you are restricted to be on the circle. So there are subtleties here. You cannot directly say stuff, but for our purpose, yes, that is true, that there is only one shortest path from P to the line XY, because we are restricted to something called the Euclidean space. And Euclidean space is nowhere to be found except in the mind of a mathematician. Our universe is not Euclidean in that sense. Maybe not Euclidean. Most physicists think our universe is not Euclidean. Okay, so coming back to what we were doing, we were trying to, oops, sorry, I just deleted everything. So let me quickly draw that A, B, C, and A, X, Y. And we have this base, like this. This is the thing. This is the other thing. We want to find out, Rashmi, can you switch off the video, please? Please switch off the video, Rashmi. Okay, she doesn't understand how to switch off the video. That's a bit weird. Maybe I can go back and switch off this video. Okay. Okay, if I'm unable to switch off the video, I'll just remove her. Okay. Okay. I don't know if there is a, I don't know if there is a automatic switch off option for everyone. Like, people are kind of stupid. They're switching on the video when they're seeing not anyone else is switching on the video. This is really weird. Okay, now it's fine, I guess. Yes, that's great. Okay, so we have this. Sorry. So what is the ratio of area of ABC with AXY? So area of ABC is, this is height, half height times BC. Area of AXY is half height times XY. And we cancel this off. So this is BC over XY. It's one of the most simplest ideas, that if these triangles share the same vertex and if their bases are on the same line, then the ratio of area is equal to the ratio of bases. ratio of area is equal to the ratio of the bases. Seems like one of the most simplest ideas in geometry. It's used widely throughout the spectrum. So we are ready for the problem. Let's look at the problem one more time. So the first thing we see is that AD over DC is 1:2. So can anyone tell me what is the area of triangle ABD over triangle ACD is? Area of triangle ABD over triangle ACD. We know that AD over DC is 1:2. We know that AD over DC is 1:2. This is something we already know. See, both of them are sharing the same vertex B. Both of them are sharing the same vertex B, and their bases are on the same straight line. Their bases are on the same straight line. Both of them are sharing the same vertex B, and their bases are on the same straight line. I made a mistake in writing? Okay, maybe. Oh, I made a mistake in writing. Sorry. Thank you. This is BCD. You are right. Good. Correct. Thank you for understanding. You're right. My mistake. Correct. So ABD by BCD. Correct. So we can find, so this is 1/2. 1/2. Okay, so now this is fine. Now let's look at AEB. Let me not make a mistake this time. AEB over AED. What is the ratio of that area? So these two are 1 and 1, right? This is 1 and 1. 1:1. So this is 1. So what I'll do is I'll give some algebraic symbols to these. So if AEB is X, if this is X, then what is AED? If AEB is X, oops. If AEB is X, so then AED is also X. Okay, Harshita is saying, why is it 1:1? Very good question. See, E is the midpoint, right? So BE over ED, this is BE over DE, because that's the ratio of the bases, right? And they shared the same vertex A. Same vertex A, and the bases are BE and DE, right? This is in fact one of the simple intuitions of geometry that we often miss, that the median actually divides the triangle into equal area parts. The median divides the triangle into equal area parts. Median means the line joining the vertex to the midpoint. Right? Okay. So this is X then. All right. What is the area of BCD? What is the area of BCD then? Okay, ABD is X plus X, 2X. ABD is X plus X, 2X. Then BCD is twice that, because BCD is twice ABD, so that's 4X. So BCD is 4X. BCD is 4X. What we want to find out is EBF. What we want to find out is EBF. Now, friends, we can now go into two directions. The first direction is to use a very powerful theorem from geometry. It's known as the Shiva's theorem. It's known as the Shiva's theorem. Okay. But the good news is we can and we will do it without using the Shiva's theorem. Because after all, remembering a theorem is hard. And if we can do it without it, why not do it without it? So literally, we will not do without it. We will use the method of proof of Shiva's theorem to obtain the result. So if you do not know Shiva's theorem, that's great, because we will not use it at all. We will just use normal mathematical tools to solve this problem. But you do need a different concept. So let me just, oops, sorry. Let me just go into this one more time. So this is x, this is x, BCD is 2x. Maybe I can change the color. BCD is 2x. So we want to find out the area of EBF, this one. So we will not use Shiva's theorem. Oh, BCD is 4x, sorry, 4x. And ABD was 2x. We will be not using Shiva's theorem. Instead, we will use something else. Let's see what we can use. So we will do a simple construction. Let's join EC. Let's join EC. Can anyone tell me what is the area of triangle ECD in terms of x? So you don't need to tell me the actual area. Just tell me the area of triangle ECD in terms of x. Perfect. It is 2x because E is the vertex, EAD is x, then ECD is 2x. It's twice because the base is twice this base. DC is 2 times AD. So we are using this, right? It's 2x. Perfect. Perfect. Now, we are almost at the end of the problem. You see, can anyone tell me what is the ratio of triangle ABF over ACF? ABF over ACF. It is equal to the ratio of 2 pieces of sides. It is equal to the ratio of 2 pieces of sides. There will be no numbers or x involved in your answer. 2 pieces of sides. Okay. So it is indeed BF over FC. BF over FC. Can you also tell me another ratio of triangles which is BF over FC? Can you tell me, so this is BF over FC. Can you tell me another ratio of triangle which is BF over XC? Excellent. So this is the trick. You look at EBF, you look at EFC, and this ratio is also EBF and EFC. This ratio is also BF over FC, BF over FC, right? Now, we will be using something called subtrahendo. What is that? If you have 2 ratios, A by B equal to C by D, then each of them are actually equal to A minus C by B minus D. For example, if you have 10 by 20 equals to 6 by 12, not sure if that is right. That is right, isn't it? It's correct. So you can just subtract the numerators, 10 minus 6, and subtract the denominators, 20 minus 12, and you get the ratio, the same ratio. There is a way to prove this. It's a very simple algebra exercise. I'll ask you to prove it. Okay, so now let's use this here. So then this is equal to ABF minus EBF divided by ACF minus EFC. Okay, what is AB? So what is ABF minus EBF? Can you look at the picture and tell me in terms of X? ABF minus EBF is just this much, which is X. Excellent, excellent. ABF minus EBF, you chop it off, and that's X. What is ACF minus EFC? What is ACF minus EFC? Well, that is 3X. So you immediately know what is BF over FC. Can anyone tell me what is BF over FC from this? It's 1/3. Excellent. Now you should be able to complete the problem. You should be able to complete the problem. Before we switch it off, let me remind you that this is a workshop for the Bose Mathematics contest that is coming up in the month of July. So it's a math Olympiad that will be attended by students, online math Olympiad that will be attended by students all around the world. You can go to chinta.com/Bose to attend it. So it's to register for it. Registration is free, but you can also go to Academy and attend the Math Olympiad program to master these ideas. The free workshops will be again next week. We will notify you about the time, but till then, you can definitely go to chinta.com/Bose, chinta.com/Bose to. It's not very hard. It's actually very interesting. If you love mathematics, you will love it. So chinta.com/Bose to attend this Math Olympiad. It will be conducted online, the first round and the second round, and there are very interesting prizes at the end of it. Using the fact that BF over FC is 1/3, I want you to find out the final answer EBF, of the value of EBF, the area of EBF. You should be able to do it right now, and the final answer is, you can send the final answer to helpdesk@chinta.com. Okay, so all of you stay safe and stay well. I will see you next time, and we will do some fantastic mathematics together. We will enjoy the subject, okay? But for now, we will stop here. Take care and all the best, and good night to all of you if you're from India.